Welcome to MacRack's video series about warehouse collapse and 2 keys for prevention. Let's dive in. So, warehouse collapse, according to the engineer Sal Fatine, who has worked in this engineering area for over 35 years, small mistakes prime a warehouse for collapse. What we're looking at are the tiny little details that you as a warehouse manager don't do or allow to happen and go unrepaired or unaddressed. That leads up, it lights the fuse on the bomb, and it's something larger that we'll look at later, a trigger event that sets off the entire collapse. So the real key is to look at what are the small steps that lead us into this danger zone. So the first thing that we have to deal with is priming issues of an engineering nature. So most of us are not looking at what we call the LARC plans every day for our warehouses, but those plans, those engineering plans, are very significant because in order to make your warehouse work and your racking system work, it was engineered to a specific weight, to a specific structure, a specific loading pattern. All of these things were presupposed when they designed your racking system. And over time, your warehouse needs may have changed. You have to make sure that wherever your warehouse loading patterns are and your warehouse uses patterns are identical to the identical specifications of the engineering. It's very important that you keep in mind that these engineering specifications need to be at hand and followed at all times. And if any doubt rises, you should contact a professional immediately and take a look at the plans, and they can advise you as to whether you're still within the specifications. All right, so what we're looking at here is a supermarket in Brazil. And then what you're going to start to see here is, due to improper installation of these warehousing racks that are being used as shelves in the stores, that the whole racking system starts to fail. And it has a cascading effect on the entire system of racking. So we see the people here returning back in here, and unfortunately there was a fatality in this accident. So fatalities are the worst thing that could happen in these warehousing accidents, and we try to prevent that, the loss of life or injuries, more than anything else in these scenarios. The best that we could hope for is that we've only lost the inventory in our warehouse, but of course we want to try to prevent that, and engineering is one of the key things that prevents the failure of racking, is to have the engineering specifications followed to great detail. So what we're looking at here is, you'll see this rack with no interference, no trigger event at all. It just suddenly starts to fall. So some overloading happened, engineering specifications weren't followed, and you can see the whole rack comes tumbling down and affects the racks next to it. We don't know what happened to this individual in the racking system, but following your engineering specifications, not overloading it, making sure that you have all the bracing involved and everything involved in it, is highly significant, or else you could have this kind of catastrophic event happen within your racking system. All right, so our second priming issue is alterations from the original engineering and pallet rack standards. So oftentimes what you'll see happen is a beam gets moved, and you think moving a beam is not going to be that significant event in the overall structure of what we do within our pallet racking system. However, when a beam is moved, it can cause all sorts of new torsions to happen within the racking system, because the racking was designed to have a beam at this height and standard heights. It increases the rigidity of each frame, and when you move that, the frame becomes less rigid, and you've altered the engineering. So this is one of the things that happens all the time. People might use moved beams, they might move struts, and they think, oh, this is a modular system that I can just assemble it in any configuration that I want to. But you need to consult your engineer before ever reconfiguring any part of your warehouse racking system. Okay, priming issue number 3. Again, priming issues are the small things that you could do wrong that can lead to catastrophic failure. Number 3 issue is loading issues. So let's look at that. This is a prime example of loading issues in my mind. Let's look at this video. And what we're going to see happen in this video is we're going to see that the operator here removes a pallet and then decides to put it back in for whatever reason, and just slightly bumps the racking system when he puts it back in. Okay, notice what he does here, and you'll notice that already something is starting to fall from the top. That's probably a good indicator that this racking has been overloaded. Now notice that the rack falls from the top first and is not being kicked into the middle, it just falls straight down. That's an indicator of overloading mostly. And then you'll see when we get to this other side here, you'll be able to see that there are boxes and boxes that are stacked on this top frame here that indicate that there is more product that is being overloaded on the top. That's a key sign of overloading your racking system. And so this overloaded racking system that was probably pushed beyond the engineering limits led to catastrophic failure. So you think you can push your system, you can say it's been holding up for years, we've done this forever, until the stresses are just too much on your system. All it takes is a small tap from one operator, and that which is the triggering event, and all that priming weight comes tumbling down in your system. All right, let's talk about the priming issue number 4, collective damages. So the collective damages are the small things that happen, the dents, the bumps, the nicks, the things that you haven't dealt with, that you haven't addressed within your system. And these are small priming issues. You think one small dent is not going to be a big issue, but it's the cumulative effect, according to Salfontaine, that has this explosive effect on the whole, because people don't take into consideration that the engineering of the entire system with all the cross beams and the structural systems are significant. So one of those components that becomes weak can be the cumulative effect of damaging. Related to that is failure to inspect. Now, inspections are what help us to catch those small cumulative issues and report them back to the warehouse maintenance crew so that it can be taken care of. Now, if you don't have a professional to do this, you can call MacRack, and we'll get a professional out there to inspect your racks to make sure that those cumulative damages do not happen. All right, so what we're going to be looking at here is something that I think is a warehouse collapse that shows a accumulation of small effects. What we're going to be looking at here is this racking system here. Now, it might be overloaded. It might have accumulation of small components that have been broken into over time, and I'll tell you why I think that. This forklift is just going to tap one of the columns, and usually when we have column failure that kicks something out, we see a massive explosion in towards that column. Instead, we see a massive failure that goes straight down and then falls over. So let's look at what happens here. So slowly, you can see he's trying to scooch by here, but the weight of his load finally taps a column right here. And when you see that column get tapped, it does damage that column. And when you see that column get tapped, it causes a ripple effect down. This goes down instead of in, and then this goes over like that. So that, in my mind, is indicative that there wasn't just this triggering event that happened, but there must have been some sort of cumulative engineering failure, a cumulative collection of small dents, missing components, things like that that were within this part of the system that caused failure of this racking system. And again, this is what we want to avoid. We want to avoid loss of life, injury, and of course inventory loss and all the other routine things that would shut down your warehouse for weeks to get inspectors and OSHA in here to try to correct these kind of problems. So this is what we want to try to avoid in our racking systems at all costs, the cumulative damages that can cause these kinds of failures. So this is priming issue number 5, racking out of plumb. And it could be a mere ½ inch over the 10 feet span that is a rack out of plumb. So you might not see it, so you need to put a plumb line on your racking systems, make sure that your racking systems are indeed plumb. And if they are not, you need to call a repair professional and make sure that your anchors and shims and everything is corrected so that this can be truly a frame that you can be trusted. Okay, let's look at priming event number 8, failure to protect your uprights. Now these massive forks are going to be your worst enemy, and because of the weight and the mass and the inertia behind them, they can do a lot of destructive power in priming your racks for failure. So what we're going to look at now is another video that shows a collapse that happens. This collapse, I believe, could have been prevented had they had rack guards installed at the bases of their columns. Now you can see that in these columns there are no rack guards, and unfortunately this operator is asleep at the wheel, literally. But these kind of things happen. A slight inattention where the operator is looking the other way, and you've got this scenario. If you've got rack guards installed already, you're going to prevent this failure from happening. So let's look at this video. So this shows if there were rack guards and protectors at this impact point, this could have been prevented. Now what you'll see is that the material falls in the direction of the broken column. That's indication of a broken column failure. And so if they had had protection in this particular event, they wouldn't have had the catastrophic failure that they see here. All right, so we're going to look at our next priming event. All right, the next priming issue, number 9, is flexural and flexural torsion deformation. Now, what does that mean, and how is this affected? Now, this is something that isn't apparent to the naked eye or isn't common sense on how structures work. So I'm going to show you another brief video that shows you how, when you've got uneven loading or maybe misplaced beams, that you're going to start to get torsion on those roll form, particularly on the roll form type of racking, that's going to start to buckle and twist it out of its true strength, which is vertical vector strength, into horizontal strength vectoring. And let's see in this next video how an I-beam turns from vertical into horizontal strength. What you see in this video is an I-beam that usually gives great strength in one direction, but once it starts to get a little bit twisted, that the design of the beam starts to fail structurally because it's no longer being supported by the design and the engineering of what an I-beam or what a racking column is designed to do. You can see how the horizontal forces on beams can start to cause failure, and that's exactly what happens in a lot of racking systems, a lot of engineering, structural engineering systems. You see the beams get horizontal forces that they were never designed to support. And this looks a lot like what could happen to a column if horizontal forces like uneven loading, certain types of bends, certain types of twists, the lack of lateral supports like struts and things like that can cause the beam to go off its center line and have torsion, distortions, and deformations that will cause the I-beam, that will cause the column to lose its strength due to various forces that we're seeing here on the screen. So just like you can bend the ruler in this direction, but you can't bend it in the other direction. That's exactly what's happening to your columns. It's being bent in a direction that it wasn't designed to handle. And you'll start to see kinks and deformations within your column system. So this needs to be checked for, and it needs to be prevented by following all the other engineering principles that we've been examining so far. This is another priming issue that is often overlooked. Okay, priming issue number 10, the failure to anchor. Okay, so according to Nelson Architectural Engineers, 2/3 of the reasons why there were collapses were because of missing anchors. It was one of those contributing priming issues towards the overall collapse of the racking system. Without the anchors, you start to see compounding factors. The racking getting out of plumb, out of true, and the torsion starting to happen. All the different effects that we started to talk about in this series are primed because of the missing anchors at the foot plates of your racking system. So it's critical to inspect and to keep those in good maintenance. So the next priming issue is fire safety neglect. Now this can happen due to the fact that you're not giving proper spaces in your flues, you're not giving proper attention to your sprinkling systems. What you need to do is follow your fire codes within your area to have enough spacing for the type of product that you have to allow for air and for sprinklers to be able to suppress fires within your warehouse system. Without that, you could have some catastrophic failures. Now we're going to look at major triggering events. So all of those things that we've been looking at now are what we call minor priming events. The small little things that don't seem like a lot, but cumulatively add up to a big deal that when you have one of these triggering events happen, your entire system could fail. So what are those triggering events? So the most classic event is a forklift impact. Now we're looking at least 9,000 pounds of impact. So imagine a 9,000-pound wrecking ball smashing into one of your columns. That's the effect that a forklift has on your racking systems. It can be catastrophic. So as the speed of your forklift increases, so does the impact. So you can imagine a 9,000 wrecking ball just being lifted and a few inches away from your racking system is going to do a ton of damage. Move it away 4 or 5, 6 feet and then let it fly onto your thing uninhibited. It's going to do catastrophic damage. And if you've got some of those other priming events going on within your system is going to be overloaded and it's going to collapse. So triggering event number 2 is seismic events. Seismic events are the earthquakes that happen within your area. So what does that look like? So this video shows how the seismic event will affect your racking system. And note that there are liquids within this racking system which it causes even more seismic energy to be going horizontally. It's the horizontal energy that does the most damage in a racking system because it's designed to hold vertical energy and support it. But when the horizontal and side-to-side energy starts to happen, you'll start to see that the system gets overloaded and it will collapse. However, in most seismic areas, your racking system should be engineered to withstand any of these kind of forces. Perhaps they didn't confer with their engineer that it was okay to store liquids within their seismic zone on that type of racking system. So it's critical, again, to make sure that you follow your engineering. That was the priming event that may have led to the major trigger of a seismic event or earthquake of taking out this racking system. So you can see how the combination of these two cause these events to happen. Okay, trigger event number 3, falling product or beam collapse. So a lot of times what can happen is as a operator is moving in and trying to put a pallet on a rack, it can slip off of the forks and begin to tumble. And depending on the impact of that, it could be 4,000 or 5,000 pounds coming straight down onto a beam or beam below it and cause the catastrophic event to start to happen. Triggering event number 4 is resonance triggering events. This is something that usually happens when you have a cascade event. When part of your racking has already fallen down, you're going to see these what are waves going through the racking system, which are very unusual. You have to stop the frame to see them. But these are what we call resonance effects. You could see bridges that have resonant effect, and all of a sudden you'll see in these videos that we're going to look in a second that the resonant effect takes effect. You see waves of energy sort of traveling down the racking system, and then suddenly the whole racking will fall straight down. It'll be a catastrophic, almost instantaneous failure of the entire racking system. All right, so let's look at this video. This video is going to show an operator coming down the aisle here, and he's going to try to scooch by here, and he's going to strike a beam. Again, we could have overweighted systems here. We could have a lack of good maintenance in this warehouse, several triggering issues, several priming issues rather, that are compounded for this instantaneous failure here that happens. And notice it falls down and towards the system because the column broke. And then it's falling in towards the breaking columns. But what I want you to notice in particular is when we get to the second half of this, that it will send a shock wave down this, and we're going to look at, in particular, the shock wave that happens here. Look at the shock wave that comes and causes a ripple effect to happen here, and the whole column, the whole system's to fall straight down all at once. That's because of the resonance effect on the steel system. All right, triggering event number 5, we talked about fire triggering events. Now, fires can be catastrophic for warehouses, and that's why those little maintenance issues of having the correct spacing between your aisles, the correct flue clearance, that your products are not being moved back into that flue and causing sprinklers to be inhibited and the ventilation to be inhibited. So it's very important that you inspect and keep your racks within good working order so that fires don't get triggered within your warehouse systems that cannot be suppressed quickly. So what we want to avoid is something like what happened to this Kansas City warehouse, where a fire was triggered and the suppression systems were not able to keep the fire out in these racking systems, and you could see it spread from one rack to the other and caused a catastrophic failure of this warehouse because of the small priming issues that weren't followed. So it's very important that you work with your fire professionals of your area to make sure that you have the proper materials and the proper safety procedures in place to keep this from happening to your warehouse. So we're wrapping up here our discussion about the priming effects of things that can prime your warehouse for destruction, so it can be triggered by a major trigger event and cause a catastrophic event to happen. So what you want to do is you want to be able to contact one of your MacRack representatives early and often so that they can be involved in the safety setup and procedure and maintenance of your warehouse to make sure that you are operating safe, that you have protective guards in place, and that you are following all the procedures that will prevent your warehouse from ever seeing a catastrophic event like we've seen in these videos today.